Engineering design is the iterative problem-solving process that creates a solution to meet client needs. The solution can look like a device, a product, a process, or a system. Many models exist that capture the engineering design process in graphical form. While some of the terminology or some smaller features may vary, there are several common elements across all of these different models. The first is that the engineering design process is iterative. What I mean by this is that teams may need to go back and perform the same function more than once they've learned new knowledge. The second is that the engineering design process can be broken up into two overall stages. In the first step, the team immerses themselves in understanding the design problem. In the second stage, the team immerses themselves in constructing a solution. Here are several pictures of engineering design process diagrams. Throughout the developed modules, we will be using this representation of the engineering design process. Teams and courses using different models will find that most of the same steps will be found in their model. The purpose of this video is to give an overview of the engineering design process. We're going to illustrate the design process by considering two separate problems. The first, the design of a portable music player. The second, the design of a water bottle. The left-hand side of the chart is the design analysis stage. In this stage, teams immerse themselves in understanding the problem. It is critical to thoroughly explore and complete these steps. Oftentimes, teams rush through this as they don't find it particularly interesting. However, doing this step well will set your team up for success. The first step in the design analysis stage is to clarify the team assignment. It's important to start with a clear understanding of your team's assignment. You often understand this assignment by having conversations with the client or with the boss. Often, misunderstandings can arise during this step. Failure to fully understand your assignment can result in your team solving the wrong problem or solving a problem incompletely. For example, if you were tasked with designing a portable music player, you might talk to the Vice President of Development to understand the target audience for the new music player. The second step in the design analysis stage is understanding the problem and the context. The goal here is to fully understand why a design solution is needed, what has failed with previous solutions, and what new features are needed for the design. The tasks in this step include research, talking with people, and going to destinations to learn more about the problem. It's also critically important at this stage to talk with users of the design. So let's suppose you're tasked with understanding the problem and the context for a portable music player. What type of research would you need to do? What type of people would you need to talk to? And what destinations might you visit to understand the problem better? So pause the video now, take 2 minutes, and jot down some answers to these questions. The third and final step in the design analysis stage is defining the design criteria. This is the step when you formally define the design goals. These design goals are typically expressed as design criteria, with an objective paired with a quantitative value. For example, the device must weigh less than 5 kilograms. So consider the water bottle or the portable music player design challenge. Think about 2 appropriate design criteria for one of these problems. Pause the video now, take 2 minutes, and write down 2 design criteria for one of these challenges. Remember to keep your design criteria quantitative. Armed with the design criteria, your team can now move on to the solution stage. The right-hand side of this engineering design process chart is the solution stage. This is the time when finally teams begin to think of candidate solutions. By doing a good job in the design analysis stage, the team is prepared with the appropriate knowledge and ready to tackle this challenge. The first step in the solution stage is to develop solution options. This is where the team begins to brainstorm options. The goal in this step is to identify as many possible solution options as the team can. And using a disciplined process will definitely increase the number of ideas. So off the top of your head, you might be able to think of a number of new ideas for the design of a portable music player or a new water bottle. The second step in the solution stage is to evaluate solutions. When you evaluate solutions, teams use structured engineering decision-making tools, where the goal is to reduce a large number of solution options down to a selected design solution. During this process, teams use engineering techniques that include screening and scoring matrices. The process for selecting a solution is iterative and at times tedious. However, it's very important to do this step with integrity because you're essentially identifying the best designed solution. The third step in the solution stage is to prototype the solution. In this step, teams specify their solution and build a CAD model or a physical prototype. CAD models are particularly good for visualizing the solution or being able to design intricate parts. Physical prototypes are suitable when you're constructing a device. When you think about building a physical prototype, you want to initially use low-cost materials. Then, as you develop and refine your solution, you'll move on to higher cost and higher fidelity materials. The fourth and final step of the solution stage is to test the solution. Here, you test the solution to see if it meets your design criteria. In other words, does your developed solution meet the project's goals and objectives? Let's take another look at the model for the engineering design process. When you look at this diagram, you'll see that there are several back arrows. These are places where teams may need to revisit steps. For example, the process of evaluation oftentimes generates more solution ideas. Also, the process of prototyping and testing is very iterative. Don't be afraid to repeat a step to improve your design outcome. In conclusion, the engineering design process is an iterative process of creating a solution to meet desired needs. The engineering design process is a disciplined method to solve open-ended and challenging problems. The engineering design process is used throughout the field of engineering, and mastering it will allow you to work on exciting engineering design problems.